So we are beginning on the Unit 2 pretest, and questions 1 and 2 ask us to translate the following sentences into an equation. So how I like to work on these is as I'm reading it, I then write down what I see. So as I see 7 more than the product of a number and 3 is 9. So I know I'm going to have 7 more than is plus the product of a number and 3, and then down here it says use the variable x for the unknown number. So then I know the product of a number and 3 is 3x. But more than is one of my turnaround words, so I'm going to take 3x plus 7, and then anytime I see is, I think equal sign, 9. Number 2 says the product of 4 and Matt's height is 52. Use the variable m to represent Matt's height. So where I see Matt's height, I'm going to put m. I know product is multiplication, so I've got 4 times m is my equal sign, 52. So your final answer is 4m equals 52. Moving on to problem 3, we're just solving these one-step equations. So this is my variable side, this is my number side. I want to leave my w on this side, so I need to move my -6 here. And to do that, I use my inverse operation of addition. What I do to one side, I do to the other, and I'm left with w equals 14. Problem 4, same one-step equation, but we're solving for v now. We have v divided by 4 equals 76. We are going to multiply both sides by 4 because our inverse operation of division is multiplication. Multiply by 4, our 4 is canceled, and you're left with v equals 304. Remember, you do get to use calculators on this test. Then problem 5 says to solve for y, we're going to simplify our answer as much as possible. It's -20 equals -5 times y. We have multiplication. We have to undo that. So we are going to divide by -5. Those cancel. Divide by -5, and you're left with y equals -20 divided by -5 leaves me with a positive 4. Remember, you need to make sure you divide by that negative. I want to know what y is by itself, not negative y. We're moving on to page 2. It's problem number 6. We're solving for u. So now we're here at the 2 steps. Remember, we're sort of doing inverse operations, or the reverse order of operations here, or another way to think about this is make your do and undo column. And then a third way to think about it is you want to do whatever operation is connected to your variable that you're trying to solve for last. So that's the last thing we sort of want to mess with. So we're going to add 6 to both sides because we want to cancel that -6, and what you do to one side you got to do to the other. So we're left with 4u equals -16. Now we just divide by 4 because it's 4 times u. To undo that, we do division, and we're left with u equals -4. Problem number 7. Now remember, with these, before I move on, you can always check your work. There is no excuse on your test why you shouldn't know if you got your answer correct or not, because you can go back and check it. So to do that, remember, wherever you see a u in the original equation or whatever variable you're solving for, you replace it with that number. So we'd take -6 plus 4 times -4 equals -22, and you would balance that out and check it, and yes, it does become -22 equals -22. Okay, now moving on to problem 7. We have 14 plus 12u equals -16 plus 9u. I'm going to sort of scoot this over to give me some area to do some work. I'm going to start by recopying it over here. I've got 14 plus 12u equals -16 plus 9u. We're going to do 2 things at once here because we don't want to work too hard. Now remember, we make our variable side the side with the biggest variable. So 12u is bigger than 9u, so that's going to be our variable side. This side's going to be our number side. So I need to get all my variables on this side. So we got to move this 9u over here, and I need all my numbers on this side. So I got to move this 14u. To move my 14, that's the first thing I see that needs to go on this side. Remember, I would circle them because they don't belong. We're going to subtract. That's a positive 14. We're going to subtract 14 on this side. Those cancel. Then we're going to subtract 9u because it's plus 9u right here. Those cancel. Subtract 9u. We're left with 3u equals negative 30. Divide by 3. Divide by 3. U equals negative 10. Again, you can check that work. Now we're down here on problem 8. I'll do the work on problem 8 on the left side over here. We have 7u plus 4 times the quantity u minus 7 equals 27. First thing here, I'm going to distribute. Remember, don't call me after midnight. It's another one of our notes we had. We had distribute, combine like terms, move the variable. So let's start by distributing. We have 7u plus 4 times u is 4u, and 4 times negative 7 is negative 28, so we have minus 28 equals 27. Combine like terms. 11u minus 28 equals 27. Now we're going to keep this our variable side, and this is our number side. So we're going to move this negative 28 because it does not belong. So we're going to add 28 to both sides because the inverse operation of subtraction is addition. And you're left with 11u equals 8 plus 7 is 15. Add 1 up there, that's 55. 11u equals 55. Divide by 11. Divide by 11. U equals 5. Again, you can check that. Now we are moving on to absolute value. When you're working on these, think about what the question is asking. It wants to know inside our absolute value bars here, negative 4 plus 9. Well, negative 4 plus 9, we're going to keep our bars here, is 5. Well, what's the absolute value of 5? What is 5's distance from 0? Well, that's an easy one. It's 5. Now we have the absolute value of negative 4 plus 9 outside of those absolute value bars. So we want to know what's the absolute value of negative 4. Well, negative 4's distance from 0 is 4 because distance is always positive. Then we have 4 plus 9. That simplified equals 13. Same thing down here on 10. Negative 4 plus 7 is 3. Then the absolute value of 3 is 3. Negative 4's absolute value is 4 because it's a distance of 4 from 0. Distance always positive. Then we have 4 plus 7. That simplifies down to 11.
Coach Alice.
Problem 11 asks us to solve for u. So we are going to set up our equation and we are going to lose the absolute value bars. So we have 5u minus 10 equals 0. Normally we would set up our two equations. Say this was set equal to 3. We would have 5u minus 10 equals 3. 5u minus 10 equals negative 3. But there's only 0. There's not positive 0 and negative 0. It's just 0. So now we solve. We have our variable side, our number side. Negative 10 does not belong on the variable side, so we got to add 10, those cancel. 5u equals positive 10. Now it's just a one-step equation. 5 times u, we undo that multiplication by division. Divide by 5, and you're left with u equals 2. Again, you can check this. 5 times 2 is 10. So that's 10, and then we have minus 10. So 10 minus 10 is 0. Yep, that one checks. Problem number 12 here. Before we begin this, I know it looks like if we look at it right away, quickly it looks like it could be no solution. But we have to isolate our absolute value bars. So we need to get this by itself first before we set up our two equations. So to do that, we're going to add 32 to both sides. And that leaves us with the absolute value of 4u equals 0. This is just like problem 11. 4u equals 0. We're going to divide by 4, u equals 0. If we have 4 times u, that's 0. Yeah, 4 times 0 is 0. Minus 32 on our check. 0 minus 32 does equal negative 32. So that one again is correct. Now with problem 13, we are moving on to ratios and proportions. So to solve for x, we need to cross multiply. So we're going to say 2 times x, or 2 times 6, that's 12, equals 4 times x, that's 4x. Now we just, it's a one-step equation, so another way to think of it is cross multiply and divide by the third. So now we divide by 4, 12 divided by 4 is 3. That equals x. Problem 14, we're doing the same thing. 3 times 11 is 33. 8 times v is 8v. Divide by 8, divide by 8. V is about to 1 decimal place. I think when you type it in your calculator, you get 4.125, but we're rounding our answer to the nearest tenth, so that's 1 decimal place, so that's going to be a 4.1. Problem 15, we're doing the same thing now, but down here we have this x plus 3. So we have to distribute our 8 to that. So I set it up by saying 12 times 5, that's 60, equals 8 times our quantity x plus 3. We're going to distribute, so we have 60 equals 8x plus 24. Now it's a two-step equation. This is what we're focusing on last. We got to move this 24 first. We're going to minus 24, minus 24. 32 equals 8x. Divide by 8, divide by 8. X equals 4. And again, you can check this. Same thing on 16 down here. Cross multiply. We have 3 times the quantity x plus 8 equals 18 times 2, that's 36. 3x plus 24 equals 36. Minus 24, minus 24. Remember, this is last, so move everything else first. Those cancel. 3x equals 12. 36 minus 24 is 12. Again, you'll have your calculator. 3 times x, so to undo that multiplication, we're going to divide by 3. What you do to one side, you got to do to the other. You're left with x equals 4. Now, down here on 17 and 18, these are proportion problems again. It says, there is a sales tax of $25 on an item that costs $310 before tax. The sales tax on a second item is $10. How much does the second item cost before tax? So when I set up these proportions, I'm going to have the amount of tax over the cost, and I'm going to set that up same proportionally as tax over cost. So item 1 was $25 in tax over $310 cost. And then my second item is $10 of tax, but I don't know that cost, so I'm going to call it X. Now, again, just cross multiply and divide. So you have 25 times X, that's 25X equals 310 times 10 is 3,100. We're going to divide by 25. Divide by 25 because we want X by itself, and you're left with X equals 124. Again, when you're looking at these, make sure your answer is reasonable. That tax of the second item is like less than half of the original tax, so that cost has to be less than half of the original. I wouldn't want my cost to be more than that first item. Problem 18 says Layla made $95 for 5 hours of work. At the same rate, how much would she make for 9 hours of work? So we're going to have our hours over our pay. So that leaves us with 5 hours for $95, and that's our rate there. We want to know how much if she works 9 hours. So you want your hours over your money on both, over x. Again, you're just cross multiplying. So 5 times x is 5x. And that's equal to 9 times 95, which is 855. Then we're going to divide by 5, and you're left with x equals $171. And again, make sure your answer is reasonable. For 5 hours of work, she got $95. So for 9 hours of work, it kind of makes sense, yeah, that she would get $171. Problems 19 through 21 are literal equations here. We're just solving for our variable. Remember, you're not looking for one specific answer. You're more or less just rearranging the equation. So on problem 19, it says to solve for Q. So I'm going to highlight Q here. Everything else needs to go. So this needs to be moved and this needs to be moved. Well, to move it, I got to cancel it out. So I'm going to, from minus R, I'm going to add R. I'm going to add R to both sides. And at the same time, it's plus S, so I got to subtract S and subtract S. There we go. Those both canceled, and I'm left with Q equals P plus R minus S.
Ms. Hebler.
We have the same thing down here on 20. It says to solve for M. So I want this M by itself. I am left with M times X equals Y. So to undo that multiplication, I have to divide by X, and I'm left with M equals Y over X. All of you know how to do this with numbers. Do the same thing with your variables. You're just rearranging it. Don't overcomplicate it. We don't know how to solve them. We don't know what Y is. We don't know what X is. So we just have to leave it as M equals Y over X. Now, problem 21 says to solve for X when we have 7 times the quantity X plus 1 equals 9. When we're doing these, I know we like to think we need to distribute first. Don't do that. Think of it as 7 times this other piece. So it's 2 pieces there. So to undo that multiplication, we're going to divide. So I'm going to divide by 7, and that helps us to get rid of our parentheses. And I'm going to divide by 7 on the other side. So when I rewrite that, I'm left with X plus A equals Y over 7. Now I want the X still by itself. So I'm going to subtract A, and you're left with X equals Y over 7 minus A. And that's all.